Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. You know, the year 2016 came down as one of the historic years in politics. However, most people have spent their time looking at the floor, putting their head down, but not looking up. So this is what I want you to do. Look up. And you'll see that there's a glorious universe out there. In the year 2016, we made incredible breakthroughs in astronomy. We discovered gravity waves, which may open up a whole new way in which to look at black holes and the universe. We discovered a planet going around the nearest star to the Earth, Proxima Centauri. The planet is a hop, skip, and a jump from the planet Earth, and one day perhaps we'll live on that planet. And then we'll say a few things about Mars, a few things about Pluto, and the exploration of the universe. Our special guest today is our favorite astronomer, Dr. Ken Croswell, author of the book, The Alchemy of the Heavens, Searching for Meaning in the Milky Way. Today, in this hour, we're going to talk about the top stories of 2016 and what a year it's been for the universe. First of all, 100 years ago. It was 100 years ago, in 1916, that Albert Einstein took his theory of relativity, only a year old, and predicted gravity waves. Not just light waves, not radio waves, but gravity waves from outer space. And one day we will use them as gravity telescopes. Gravity telescopes that will give us baby pictures of the infant universe as it was created over 13 billion years ago. This is incredible, being able to use a new kind of telescope to peer into the heart of black holes. And then we'll say a few things about Proxima Centauri, the closest star to the planet Earth. Believe it or not, the closest star to the planet Earth has a planet going around it, which is Earth-like. It has a mass just 1.3 times the mass of the planet Earth, and we think that it maybe one day will send a probe to the nearest planet with an Earth-like planet going around them. In fact, if you see the movie Passengers, starring all these Hollywood A-listers, it talks about a 120-year voyage to one of these planets, and perhaps Proxima Centauri will be the star, which is the destination for the
You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. With us on the line once again is our favorite astronomer, Dr. Ken Croswell of Berkeley. And we're going to sum up the year 2016 in the heavens. Well, 2016 was quite a year. But instead of looking down all the time and putting your head in the ground, look up. Look up and see that there's a glorious universe out there. And there's been an enormous number of breakthroughs in our understanding of our backyard. The Milky Way galaxy, we're going to talk about gravity waves. We're going to talk about exoplanets, Pluto, Mars, galaxies, you name it, with astronomer Ken Croswell, author of The Alchemy of the Heavens, and also subtitled, Searching for Meaning in the Milky Way. So, Ken, glad you could be on. Once again, Science Fantastic.
Glad to be here, Michio.
Okay, well, let's just jump right into some of the big stories. In fact, there's probably a Nobel Prize waiting for the physicists who nailed down gravitational waves. So tell us a little bit about all the excitement that's being generated in the field of physics and astronomy.
Yes, this was a great discovery that actually occurred on September 14th, 2015, but the announcement didn't come until February of 2016, so that's why we're talking about it in 2016. Two black holes orbiting around each other spiraled together, got closer and closer and closer until they merged into one even bigger black hole. One of the black holes was 36 times more massive than the sun. The other black hole was 29 times more massive than the sun. And they formed a black hole that was 62 times more massive than the sun. Now, if you add up those two numbers, 36 and 29, you won't get 62, you'll get 65. So what happened to the three solar masses, the missing three solar masses? Well, it was converted into energy via Albert Einstein's famous equation, E equals mc squared. The mass, m, in that equation was converted into energy and radiated. And we detected the gravitational waves from that merger on September 14th, 2015. As the waves passed through the Earth, they caused the detectors that detected the gravitational waves to vibrate ever so slightly by less than the size of a proton, if you can believe that. And yet they were able to detect it. So this is definitely an amazing discovery. Now, nobody really doubted that gravitational waves were out there. And in fact, decades ago, astronomers had discovered two neutron stars orbiting each other, and their orbit was decaying in a way that agreed with Albert Einstein's general theory of relativity. But this is actually a direct detection, the first direct detection of gravitational waves as predicted by Albert Einstein's general theory of relativity.
And isn't that amazing? It was 100 years ago, in 1916, that Albert Einstein predicted these gravity waves, but he despaired of ever being able to prove it in his lifetime. Gravity waves are so faint that he himself said that in his lifetime he's not going to be able to see the verification of that prediction. But bingo! 100 years later, we can now confirm that Einstein's theory was correct on the question of gravity waves. Now, some people say, well, so what? Let's say, for example, that the sun were to disappear right now. Right now, the sun were to disappear. According to Newton and according to Einstein, how long would it take for us to feel the effect of a disappearing sun?
Well, light travels at the speed of light, and so does gravity, according to Einstein. And so basically we would all get flung off into the void, all the planets, Mercury, Venus, Earth, Mars, and so forth, and we would also lose all the light from the sun. But it would take about 8 minutes for us to notice that there was something very wrong with the sun, since it takes light 8 minutes to travel from the sun to the Earth.
Okay, and also some people say that every time we discovered a new kind of radiation into outer space with a telescope, it revolutionized our understanding of the universe. 400 years ago, Galileo aimed a telescope to the heavens and using optical radiation found out that there was a whole universe out there waiting to be discovered. Then during World War II, we detected radio waves with radio telescopes, and that gave us a glimpse into the heart of galaxies. And now some people are saying we're now witnessing the third great revolution, gravity telescopes. Maybe within a few decades, LISA will be sent into orbit, which will detect gravity waves from the Big Bang itself. Isn't this incredible? I mean, the potential of looking into the heart of black holes and perhaps into creation itself using a new kind of telescope. Gravity waves instead of radio waves and instead of light waves. What are your thoughts?
Well, certainly in the future, in the far future especially, I think we can count on gravitational wave detection to tell us more about the most extreme conditions in the universe. For example, two black holes merging together, or a neutron star and a black hole merging together. I would point out that I wouldn't call this the third great revolution in astronomy. There have been a number of non-optical types of radiation that have really advanced our understanding of the universe. For example, infrared tells us quite a bit about the universe. X-rays tell us about black holes. In fact, the very first black hole ever detected, Cygnus X1, was revealed by black holes. Was revealed by X-rays emitted by hot gas falling in to the black hole. So there are many non-optical forms of radiation that have told us a lot about the universe, and gravitational waves are going to be one of those forms.
Okay. Well, moving right along, because we want to summarize some of the top stories of the past year, let's talk about Proxima Centauri. It's a star that it doesn't roll off the tongue very easily of most people. However, in the future, it could, in some sense, contain our destiny. There's a movie called Passengers, which people are talking about, where scientists are able to invent starships, and we can go to exoplanets orbiting other stars. But tell us a little bit about this discovery of an Earth-like planet orbiting around Proxima Centauri.
Yes, this is certainly the greatest astronomical discovery of 2016. It's an Earth-mass planet. It may or may not be Earth-like. We don't know. Proxima Centauri is a very nearby star. In fact, it is the nearest star to the Sun, located only 7,000 times farther than the planet Pluto. It's 4.24 light-years away. It's a very dim star. It's a faint star. It's a cool star. It's a red dwarf star. It's so dim that despite its proximity, it was discovered only in the year 1915, which, strangely enough, is the same year that Albert Einstein came up with the general theory of relativity. It is in orbit around two much brighter stars called Alpha Centauri A and B. And the excitement of this year is, as you just noted, the discovery of an Earth-mass planet that is in the habitable zone of Proxima Centauri. Now, because Proxima Centauri is so faint and so dim, the planet is actually much closer to its star than Mercury. The planet Mercury is to the Sun. But that's perfect because the star is so faint. And so this planet is actually in the habitable zone. It goes around the star every 11.2 days. So that's a lot faster than we do. We, of course, take a year to go around the Sun. Mercury takes 88 days to go around the Sun. This planet is so close to its star, just 4.5 million miles from its star, that it takes 11.2 days to go around its star. And so that raises the hope that maybe, and I emphasize maybe, it could have liquid water on its surface. And if it does have liquid water on its surface, then it could conceivably harbor some form of life, because we do know that the Alpha Centauri star system is fairly old. It's probably a bit older than the Sun. So there's been plenty of time for life to evolve on this planet if it has water and if it has other conditions that are good for life. But the really big unknown is we just don't know whether this planet has water or not.
Okay, well, even school children know that Alpha Centauri is supposed to be the closest star to the Earth, but what's the relationship now between Alpha Centauri and Proxima Centauri?
And that's another discovery of 2016. We have long thought that Proxima Centauri was orbiting around Alpha Centauri A and B, and now we've got the proof. And here are the figures. Proxima Centauri is located 4.24 light-years from Earth. Alpha Centauri A and B are located 4.37 light-years from Earth, so just a little bit farther. The two are separated by 13,000 times the distance between the Earth and the Sun, so they're very far apart. And so some people have said, well, maybe they're not really orbiting each other. But now we have new precise velocity information that indicates that, in fact, Proxima is traveling through space at almost exactly the same speed and in almost exactly the same direction as Alpha Centauri A and B. So the little star is indeed gravitationally bound to the big bright stars, Alpha Centauri A and B. Moreover, this new work, even for the first time, reveals the orbital period of Proxima Centauri around Alpha Centauri A and B. It's a long period, as you might imagine, given their huge separation, 550,000 years. That's how long just one orbit of Proxima Centauri takes around Alpha Centauri A and B.
Well, fans of Star Wars, the movie, had to withstand the criticism of scientists who said, what? Luke Skywalker looks up in the sky and sees a double star system? Such a system would be unstable. Well, here we have a triple star system, right?
Right.
And it seems to be relatively stable. So doesn't that mean that the critics of Star Wars were in some sense wrong? What are your thoughts?
The Star Wars scene involved a planet going around a double star, which we didn't know of at the time that movie came out. But, in fact, we have since discovered planets going around double stars, just as shown in that movie. So any such criticism was premature. We astronomers, or another way to put it is, I think the universe is often more imaginative than the astronomers are.
Okay, and talking about this Earth mass planet going around Proxima Centauri, right? What do we know about it other than its mass and its period? Do we know anything about its atmosphere, whether it contains water molecules or oxygen? Do we know anything about the composition of its atmosphere?
Nope. And that's the final answer. We don't know a thing. We don't know if it has an atmosphere. We don't know if it has any water. We don't know what's in its atmosphere, if it does have an atmosphere. All we know are its mass and its period and its distance from the star. And from that, we can infer that if it has an atmosphere, that it's got a pleasant climate. But the fear is maybe it doesn't have an atmosphere. Maybe it's like the moon.
This is Science Fantastic.
Astronomy in the year 2016. When we think of 2016, we take a look at what happened in politics, with the environment, with all sorts of things happening on the planet Earth. But we forget the fact that there's a huge universe out there, and it doesn't wait for anybody. It's evolving, and we have more discoveries coming in every year. So far, we talked about the discovery of gravitational waves. We talked about the discovery of an Earth mass planet going around Proxima Centauri, the nearest planet to the Earth. But there are other breakthroughs that were made in 2016. First of all, in 2015, we had the New Horizons mission, which flew around Pluto. And information still keeps pouring from as we analyze the flyby that took place. So, Ken, could you sort of summarize briefly what we learned from the New Horizons flyby of the planet Pluto as information is still being digested a year later?
I'd be happy to, because Pluto is my favorite planet, and the New Horizons spacecraft was a total success. It gave us our very first close-up view of Pluto ever. Prior to this mission, we had images, very blurry images from the Hubble Space Telescope of what Pluto looked like. But now we have it in close-up. And Pluto is an orange planet. It's got a big white heart on it, which really surprised and delighted everyone. That heart has been named for the discoverer of Pluto, Clyde Tombaugh. Clyde Tombaugh discovered Pluto in 1930. The New Horizons spacecraft measured the size of Pluto precisely, 1,477 miles, and it turns out, guess what? Just as we were told back in grade school, Pluto is, in fact, the largest object going around the Sun beyond the orbit of Neptune. It is larger than anything else out there. Back in 2005, you may recall that an astronomer discovered Eris, which is even farther than Pluto. He claimed it was definitely bigger than Pluto. He said, if it's not larger than Pluto, then I'll eat my telescope. Well, guess what? It's not larger than Pluto. Pluto is larger than Eris, and I do wonder how he likes the taste of a telescope, because I assume he is having telescope stew for dinner. Let's see, what other results from the spacecraft? The spacecraft discovered mountains on Pluto, 2 miles high, as high as the Rocky Mountains, that are made of water ice, because at Pluto's very frigid temperature, which is nearly minus 400 degrees Fahrenheit, water ice is as hard as rock, and so it can form mountains, miles high. Also, the spacecraft looked at Pluto's 5 moons. Pluto's 5 moons going around it. The largest moon, called Charon, has these enormous canyons that really surprise people. They're much deeper, much longer than the Grand Canyon in Arizona. They're up to 4 miles deep and hundreds of miles long. So a lot of great discoveries from the New Horizons mission that came out last year.
Okay, and you mentioned this strange heart-shaped object, a plane of some sort, on the surface of Pluto. We've never seen that in the solar system before. So what could cause this heart-shaped formation, which occupies roughly 30% or so of the surface of Pluto?
Yeah, that heart is bigger than the state of Texas. It's a very big feature, very prominent. Just look at a picture of Pluto from the New Horizons spacecraft, and you'll see it. The thinking is that that area, which is white, is probably made of frozen gases, frozen nitrogen, maybe frozen carbon monoxide. Nitrogen is the main gas that makes up our atmosphere. It's also the main gas that makes up Pluto's atmosphere. And so it's entirely possible that that region of Pluto, that heart, that big white heart, consists of frozen nitrogen, frozen carbon monoxide. And in fact, we have detected what looked to be glaciers of frozen nitrogen on the surface of Pluto. Again, here on Earth, nitrogen is a gas, but Pluto is a lot colder than Earth. It's, again, almost minus 400 degrees Fahrenheit, and so most of the nitrogen on Pluto is frozen solid. Just as if you could somehow lower the temperature of Earth to hundreds of degrees below zero, the gas in the atmosphere would freeze and actually snow onto the surface and become ice.
Okay, Ken, once again, we have to take a short commercial break, and after the break, we're going to continue a discussion of the universe in 2016. What kinds of revolutionary discoveries were made concerning the universe?
This is Science Fantastic. You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. With us today, once again, is astronomer Ken Croswell, author of The Alchemy of the Heavens, talking about the big stories of 2016. Like I said before, most of us spend all our time looking at our feet, staring at the ground, wondering what's next, without realizing that there's a whole universe out there. So look up. Look up and see that there's a glorious universe out there, and today we're summarizing some of the top stories in astronomy. Well, Ken, we talked about Pluto and what's beyond Pluto. Most people would say that what's beyond Pluto is nothing but debris and perhaps comets and gigantic ice cubes of some sort. However, some scientists at Caltech are now saying, no, there's a gigantic planet out there, perhaps the size of Neptune, a giant gas giant way out there. Now, this is not Planet X. I get a lot of emails saying that we're going to be heading for doomsday in the future as a gigantic planet comes barreling down the solar system and gobbles up the Earth. That's not going to happen. However, there really is something out there, right? Perhaps the size of Neptune. What are your thoughts about this conjecture?
Well, it is only a conjecture. And the fact is, over the years, over the decades, in fact, for more than a century, astronomers of various sorts have predicted unseen planets in the outer part of the solar system. And with the single exception of Neptune and Pluto, we've never found those planets. And if you restrict yourself to really big planets, then really the only planet that was ever predicted in advance of its discovery is the planet Neptune, because Pluto and Eris are not big planets, they're small planets. As to whether this new object that may exists, I don't know. I will believe it when it actually turns up. Also, since we were talking about general relativity earlier, keep in mind that in the 1800s, people noticed that the planet Mercury was off course, and they proposed that a planet existed inside the orbit of Mercury to perturb the orbit of Mercury. But it turned out, and they even named that planet the planet Vulcan. They even observed, supposedly, the planet Vulcan. But it turned out that no, Mercury's orbit wasn't off at all. It was simply the effects of general relativity on Mercury's orbit, which manifest themselves greatest closest to the sun. So I do not know whether this big proposed planet exists in the outer solar system. We will find out as the years go on.
Okay, well, summing up some of the big stories of 2016 in astronomy, let's say a few things about Mars. Mars, within 25 to 30 years, some scientists are predicting there could be a traffic jam. A traffic jam around Mars as astronauts from at least 3 different agencies and companies circle and orbit Mars and giving us the first manned landing. First, we have NASA. NASA is backing the SLS booster rocket and the Orion space module, a contraption that should go to the moon perhaps in the next decade as a trial mission to go to Mars sometime in the 2030s. Then we have Elon Musk of SpaceX, the billionaire entrepreneur who says, hey, wait a minute, he can modify his Falcon rocket and he will beat NASA. He wants to send a rocket to Mars unmanned in just 2 years' time. And he wants to create a city on Mars. Forget about an outpost like in the movie The Martian. We're talking about a city of 1 million people, says Elon Musk. And then we have Boeing aircraft, not to be outdone. Let's take a short commercial break. And after the break, let's talk about what it's like to actually live on Mars.
You're listening to Science Fantastic with Professor Michio Kaku. Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. With us today is our favorite astronomer, Dr. Ken Croswell, author of the book The Alchemy of the Heavens, Searching for Meaning in the Milky Way. And we're talking about summing up some of the big stories in 2016. One big story that hit the headlines was the fact that not 1, not 2, but 3 organizations or companies have now targeted Mars for a manned mission. Forget about sending a probe or a lander or a rover on Mars. We're talking about humans, a la Matt Damon, walking on the surface of Mars sometime in the 2030s. We have NASA laying out a 3-pronged program to begin the exploration of Mars with the SLS booster rocket and the Orion space module. We have Elon Musk of SpaceX, the entrepreneur, the billionaire, who wants to modify the Falcon rocket so he could reach Mars and create a city on Mars of 1 million people, starting with 1,000 rockets to go to Mars with 100 passengers each. Incredible. And then we have Boeing aircraft, not to be outdone. Yes, even Boeing is looking at the possibility of their sending a manned mission to Mars. Now, of course, creating a city on Mars is not as easy as you might think. The movies make it so simple, right? But, Ken, tell us a little bit about what the climate is really like on Mars and what would it be like to actually try to create a colony? What kind of dangers would astronauts face?
It would be very difficult because Mars, although the best planet in the solar system aside from Earth to live on, is still very hostile. It would be, in fact, more hostile than living in Antarctica. Mars is a very cold and dry planet with a very thin atmosphere. So you would need to protect yourself from the elements, so from the cold certainly. You would need to bring air or else extract air from the rocks. One thing Mars does have in abundance, though, is water ice beneath the surface, especially in the polar regions and at the high latitudes. So there is plenty of water there. It's just all frozen. But Mars is a very hostile planet. Even as you look at other planets in the solar system and you think they're really awful, well, Mars looks good in comparison to them. But compared to Earth, it's still a very difficult place to live.
And also, getting to Mars is no fun either, right? 9 months minimum to go to Mars, 9 months to go back. And there's a Hollywood movie called Passengers, about 120-year mission to a distant planet. That's an awful long time to spend in outer space, even if you are suspended in a pod of some sort. So, Ken, it's not going to be easy beginning the colonization of Mars, right? It's not like a Sunday picnic. You have weightlessness, radiation, micrometeorites, huge temperature differentials, lighter gravity, you name it, right?
That's right. It will be difficult. And just think, even today, how few people live in Antarctica, and they're almost entirely scientists. So I suspect the number, I'd be very surprised if in our lifetimes there's 1 million people living on Mars.
Yes, and then how do you begin to terraform Mars and make it livable? Elon Musk has dropped hints that you can nuke the ice caps. That is, drop hydrogen bombs in an airburst over the ice caps so that you would reduce fallout, but still using nuclear weapons to begin the process of melting the ice caps of Mars so that liquid water flows on the surface of Mars once again. Well, what are your thoughts about whether or not it would be easy to begin the process of turning Mars into an Earth-like environment, just like H.G. Wells once envisioned the Martians would invade the Earth and turn Earth into a Martian-like planet? What are your thoughts?
Well, in order to make Mars more Earth-like, it needs to have a thicker atmosphere so that it can trap more heat from the sun. And so anything that can be done to give Mars more air would be a good thing. I don't, however, approve of nuking the planet. I don't think that's a great idea. But certainly the planet right now, it has such a thin atmosphere, in fact, less than 1% the surface pressure of Earth, that the greenhouse effect on Mars raises the temperature only about 10 degrees Fahrenheit. Now compare that with Earth, where the greenhouse effect raises the temperature 60 degrees Fahrenheit. So clearly Mars needs a thicker atmosphere, a more pleasant climate, but it's going to take probably centuries to pull something like that off.
Okay, and you probably saw the movie The Martian, right? What are your thoughts about how realistically it portrayed some of the hazards that our astronauts would face, especially if they're left stranded on the red planet? Any thoughts?
Well, it's a very, space in general is a very hostile environment. I mean, we get used to the safety of air travel, you know, how safe air travel is. But space travel is much more dangerous, and living on Mars would... it would be a risky thing, definitely.
And also in the movie Passengers, starring all these Hollywood A-listers, it talks about suspended animation for 120 years. However, if you do the math and you try to calculate Earth-like planets that are close to the Earth, and you're traveling, let's say, at a good fraction of the speed of light, it will probably take you longer than 120 years to reach your destination, right? What are your thoughts about how far away these planets are, these exoplanets?
Depends how fast you're traveling and how close the nearest Earth-like planet is. Maybe if that one around Proxima Centauri is in fact not just Earth mass but Earth-like, well, you could do it in 120 years. In fact, you could probably do it in 20 years because that's only 4.24 light years away. But we don't know at this time how many planets out there are similar to Earth in terms of having pleasant climates, good atmospheres, and liquid water on their surfaces.
Okay, well, unfortunately, our time is up. So, Ken, once again, thank you so much for being on Science Fantastic.
You're very welcome.
Once again, our special guest today is Dr. Ken Croswell, author of a number of great books, including The Alchemy of the Heavens, Searching for Meaning in the Milky
Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And in this hour, once again, we're going to throw the lines open because this hour is your hour. Okay, well, let's move right along and take the first listener phone call.
Yes, this is Robert calling from Charleston, West Virginia. I hear you on WCHS radio. And my question I'm contemplating is the communication development over the years has been by way of fiber optics, cable, and satellite. When whoever goes to Mars, I understand it takes 9 minutes or more for the signal to return. And I'm wondering, could a laser somehow be pinpointed by computers and such so that you could have instant communication both ways? Thank you.
Well, the short answer is no. According to Einstein, and we see no deviation from this in our laboratories, the fastest velocity in the known universe is the speed of light. Laser light, even though it sounds magical because it is coherent radiation, laser light is light. It travels at the speed of light. In fact, in our physics laboratory, not too far where I'm sitting right now, we actually have fiber optic cables, and we actually calculate how long it takes to go from your left hand to your right hand. Believe it or not, it takes about a billionth of a second. A billionth of a second for light to go from your left hand to your right hand on a fiber optic cable. And we actually measure that right on a tabletop because we have the electronics to do that. In fact, when you look at yourself in the mirror, you're not really looking at yourself as you really are. You're looking at yourself as you were a billionth of a second ago. Now, when you communicate with the moon, it takes about a second for radio waves to go from the Earth to the moon. Mars, it takes about 20 minutes approximately, depending upon where Mars and Earth are located in the solar system, but about 20 minutes for a phone conversation, which is really quite annoying if you want to know what's, quote, really happening on Mars. And this is going to be a problem for the astronauts. Laser light doesn't help you at all because laser light also travels at the speed of light. And therefore, we're going to have a problem. Now, in Star Trek, they communicate across the galaxy using something called subspace communicators. Well, that's all psychobabble because there's no such thing as subspace communicators, at least not that we know of with the current understanding of the laws of physics. That's not to say that the laws of physics can't be changed in the future as we know more about the limits of Einstein's theory. But at the present time, modern physics says that light, in all its forms, travels at the speed of light, so our astronauts are just going to have to get used to it. That radio signals will take on the order of 20 minutes to go from Mars to the planet Earth. Okay, well, let's move right along to the next listener phone call.
My name's Brian. I listen in Chattanooga, Tennessee on WGOW AM and FM. My question is, it seems that one of the most prevalent problems for making any more significant advances in a lot of either time travel, space travel, which could be one and the same, is an energy source. Are there any theoretical energy sources, things that are being tested, things that have been tested and proven? Just curious. Thanks.
Well, I think you hit the nail on the head. When you watch a science fiction movie and you see time machines, you see jetpacks, you see ray guns, you say to yourself, well, gee, that's really neat. How come I can't get one at the store? Well, the problem is energy. First of all, you need a portable power pack to energize a jetpack and a ray gun. We actually have laser beams more powerful than the ray guns you see in science fiction movies, and we can create a jetpack, but the problem is to store large amounts of energy into a very small volume. A jetpack, for example, was first explored by the Nazis during World War II. The Nazis used hydrogen peroxide to create a jetpack by which Nazi soldiers could go across rivers that had bridges that were blown up. And that's one very practical application, but the problem was portable power pack. The hydrogen peroxide thing on your back only lasted for just a few minutes. It was not a weapon of war. It was only a way to navigate across obstacles. And again, the problem is the power pack. Same thing with the ray gun. Same thing with many other devices you see in science fiction. Now, when you talk about time travel, you're talking about a whole new realm of energy. You're talking about what is called the Planck energy. The Planck energy is a quadrillion times more powerful than what we find with the Large Hadron Collider, the largest machine of science outside Geneva, Switzerland. So, in other words, even though we physicists can begin to calculate what a time machine might look like, with a capital M, what a time machine might look like, we have problems with the energy. Basically, the energy you need is comparable to that of a black hole. And since we are in no way able to manipulate the energy of a black hole, it also means that we are clueless when it comes to creating an energy source for a time machine. And again, we're not sure that time machines are possible. However, the theory of time machines that is allowed by Einstein's theory requires energy on a scale of a black hole, and that's simply not going to happen to us anytime soon. So, sorry about that. So once again, yes, energy is the bottleneck preventing us from having many of the devices in the movies, for example, ray guns and jetpacks. But when it comes to time travel, we're talking about cosmic energy that we're not going to have for many a centuries or many a millennia. Okay, well, let's take the next listener phone call.
Hello, Dr. Kaku. This is Martin from Chattanooga, Tennessee. I'm listening on 102.3 FM WGOW. My question concerns the discovery of the Higgs boson. This is a particle that scientists think gives mass to objects. Do you think that we would theoretically be able to find a way to repel the Higgs field? And if we could, would this give us the chance to meet the speed of light or even exceed the speed of light travel? Thanks a lot. Bye-bye.
Well, I wish, but the short answer is probably no. First of all, the Higgs boson is central to what is called the Standard Model, which in turn is the byproduct of 50 years of investigation in terms of smashing atoms apart. We've been smashing atoms apart ever since World War II. Okay? And when we smash protons apart, what do we find? More particles. We find pi mesons, lambda mesons, k mesons, all sorts of junk coming out when we smash protons apart. However, we've been able to create a map or a zoo of these subatomic particles. It's not very pretty, but it contains 36 quarks, 3 generations of subatomic particles, 19 free parameters. It's a rather ugly theory, in fact, and it's called the Standard Model. The Standard Model fits all the particle data that we get from smashing protons apart and allows us to reconstruct what might have happened at the instant of the creation of the universe when all these particles were in play. Now, what holds the Standard Model together is the Higgs boson. It was the last particle to be discovered in the Standard Model. And let's take a short commercial break. And after the break, I'll answer the question, can the Higgs boson allow us to go faster than the speed of light? For that, you'll have to wait till after the break.
You're listening to Science Fantastic with Professor Michio Kaku. You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. This hour is your hour. Okay, so right along, let's take the next listener phone call.
Yes, this is Ray from Portland, Oregon, listening to 1190 KEX. You said that there is a positive and a negative in the universe to everyone and to everything. If there is a negative that an atheist says that there is no God, what is the positive that others can prove that there is a God or that he does exist? Maybe you can explain that to us, the positive and the negative. Thank you.
Okay, well, when we were talking about positive and negative, I was referring to the positive and negative particles of the Standard Model. And the previous guest asked a question about the Higgs boson. Let me quickly answer that question and then get into the other question of proving the existence of God. First of all, the Higgs boson is a particle that we discovered at the Large Hadron Collider, predicted by physicists over 30 years ago. In fact, I was a graduate student getting my PhD when I first heard about the Higgs boson, and the Higgs boson breaks the symmetry of the original Big Bang. Now, to do that, the Higgs boson starts off as a tachyon. A tachyon is a particle that goes faster than the speed of light, but because science and physics does not like particles that go faster than the speed of light, what it does is that it destabilizes the vacuum. In other words, the vacuum makes a transition to a lower state. Just like when you freeze something, it goes from one energy to a lower energy. And then the Higgs boson is tamed and becomes an ordinary particle that goes slower than the speed of light. So to answer the previous person's question, does a tachyon go faster than the speed of light? Only at the instant of creation. And after that, what is called breaking the vacuum. It goes to a lower energy state. And in the lower energy state, it goes slower than the speed of light. So Einstein has the last laugh. You cannot have Higgs bosons going faster than the speed of light. Now, the Higgs boson has a charge. It has positive and negative charge. And we see that there's a balance between the positive and negative charges in the Standard Model. In fact, in the universe, there's a balance between positive and negative. Equal numbers of positive charge, equal numbers of negative charge. And why is that? Because we think that the Big Bang started off with zero charge. We think that the Big Bang, in some sense, started off as the vacuum. That is, nothing. Out of nothing came an entire universe. That's why the net spin of the universe is zero. If you take a look at all the galaxies of the universe, they're spinning in all directions, right? But let's add them up. When you add up all the spins of the universe, like spinning tops, what do you get? Bingo! Zero. If you add up all the plus charges and minus charges of the Standard, what do you get? Zero. Bingo. Once again. In fact, that's why we physicists believe that the universe may have come from nothing. Because nothingness has positive and negative charges balancing out. Nothingness also has zero spin balancing out. And the total energy of the universe is probably also zero. Mass of the universe, of course, is positive because we have stars and galaxies, but gravity itself has negative energy. When you add the two together, what do you get? Bingo! Zero! And so maybe the universe did come out from the mist, as some religious people and theologians have said. Maybe the universe was for free. The universe came from nothing. Zero charge because positive cancels negative. Zero spin because all the spins cancel out, and zero energy because gravity cancels the energy of matter. Now, can you use this to prove the existence of God? I don't think so. First of all, there is a website that I've complained about. In fact, there are quite a few websites in my name that I have no association with whatsoever. This website claims that I have a proof of the existence of God. If anything, I believe that it is impossible to have any proof of the existence of God. I personally believe that 1,000 years from now, we'll still have discussions as to whether or not you can prove the existence of God, which I think is basically unprovable one way or the other. You cannot prove or disprove the existence of God. First of all, disproving the existence of God is very problematic because it's very difficult to disprove a negative. For example, to disprove the existence of unicorns. It's almost impossible to disprove the existence of unicorns. Well, let's take a short commercial break, and after the break, I'll say a few things about unicorns and this hour is your hour. Well, before the break, we had a question about whether or not you can prove or disprove the existence of God. My own personal point of view is that you can neither prove or disprove the existence of God. First of all, disproving the existence of anything is problematic. If you want to disprove the existence of unicorns, you have a problem, because no matter where you look, it's always possible that some place you haven't looked yet. It's always possible that you overlook some place, and so disproving a negative is always problematic. But also proving a positive is also problematic when there's no uniform definition of God. There's no criterion. See, in science, we believe in things that are testable, reproducible, and falsifiable. The proof of the existence of God or disproof of the existence of God is not testable, reproducible, or falsifiable. So it's like talking about unicorns or angels. Maybe they exist. Maybe someplace you will find an angel. Maybe someplace on earth you'll find a unicorn. But we have to be able to test it. And no one's been able to come up with a definition or a test of the existence of God that allows us to make measurements. So personally, I think that we have to keep the existence of God separate from science. In fact, I think Galileo said it the best. Galileo said that the purpose of science is to determine how the heavens go. The purpose of religion is to determine how to go to heaven. So in other words, religion is about ethics. It's about being a good person. It's about the standards for society of what is good and what is bad and what is legal and what is illegal. However, that's not natural law. The problem occurs when people in natural law pontificate about morals and ethics, or when ethicists and religious people begin to pontificate about natural law. That's when we get into problems. But as long as we keep the two separate, one, the domain of behavior, ethics, what is good, what is bad for society, and the other, the domain of natural law, I think there's no problem at all. Okay, well, let's move on to the next listener phone call.
Hello. My name is Sharon, and I'm from Florida, Clearwater. I would like to know, and I've asked a lot of people, and I don't think they know the answer, but they laugh. Why is the water blue, different colors blue in different parts of the world? And it's supposed to be a reflection from the sky. Well, where does the blue come from the sky? I like to know where the color blue comes from the sky to the water, but when you draw water up, it's clear. It's not blue. So I'd like an answer to this, and it's really navy blue out in the ocean. I'd just like to know where this color blue comes from. Thank you.
Okay, well, you ask actually a rather complicated question. First of all, why is the sky blue and why is the sunset red? That was first worked out by a physicist, Lord Rayleigh, in the last century, by looking at the scattering of light. Light, of course, consists of Roy G. Biv, red, orange, yellow, blue, indigo, violet. So on one end of the spectrum, we have red. On the other side of the spectrum, we have blue. Now, it turns out that light scatters when it hits the atmosphere, and blue light scatters the most. Red light scatters the least, as proven by the physicist Lord Rayleigh. Now, when the sun sets, you're looking at the sun through an enormous amount of air, much more than when you're looking at the sun at noontime. At noontime, the light is not going through much air. But when you look at sunset, because of the geometry of the situation, you're looking at quite a bit of air to go through, and that's why the blues have scattered away, leaving red. Well, let's take a short commercial break, and after the break, we'll talk about why the sunset is red, why the sky is blue, and why the oceans are also blue.
This is Science Fantastic. You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. Keep the calls coming at 866-323-2129. Well, before the break, we had a question that a lot of people ask, and why is the sky blue? Why is the oceans blue? And why is the sunset red? And it's due to the nature of light scattering. When you look at the sunset, you're looking through a lot of air because of the geometry of the sunset, and blue light has scattered away because blue light scatters the most. It scatters the easiest. So when you look straight up, on the other hand, when you look straight up, you're looking at where light scatters the least. And because the atmosphere is the shortest distance when you look straight up. So that's why blues survive the scattering process when you look straight up. When you look at sunset, that's when you have light going through the most atmosphere, and the blues have scattered away, leaving the red. So once again, the spectrum of colors goes from red on one side of the spectrum to blue on the other. Blue scatters the most. And that's why when you look straight up, you're looking at scattered light. And scattered light is blue. So when you look away from the sun, don't look at the sun, of course, but when you look away from the sun, you're looking at scattered light. Now, if you don't believe me, turn off the light in your room. All of a sudden, everything's dark. Why is that? Because you're looking at scattered light almost all the time. You almost never look directly at the fluorescent lights. You almost never look directly at the sun. You're always looking at scattered light. And again, if you don't believe me, just turn off the light in your room. So when you look at the sky, you're looking at light that has scattered the most, and blue scatters the most. Now, it turns out that blue of the oceans is due to two effects. One, of course, the fact that the sky is blue, but second, water itself is slightly bluish in color. It turns out that the reds are absorbed by the vibrational bonds of H2O. H2O consists of two hydrogens and one oxygen. That's why it's H2O, and it vibrates. It turns out the vibrational frequency of this contraption, called H2O, absorbs reds, leaving, therefore, the blues.
This is Science Fantastic. You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open now. Well, before the break, we had a simple question. Why is the ocean blue? Why is the sky blue? And for that matter, why are sunsets red? And it has to do with the scattering of blue light. Blue scatters the most. Red scatters the least. Therefore, when you look into the sky, you're looking at scattered light. Because, of course, you're not looking directly at the sun. You're looking away from the sun. And therefore, you're looking at scattered light. And that's why the sky is blue. However, when you look at the sunset, you're looking directly at the sun, looking at a large distance through the atmosphere of the Earth. And that's why the sunset is red. And the water is blue because, believe it or not, it has a bluish color. H2O is the chemical symbol for water, and it vibrates. The vibrational frequency corresponds to red. Therefore, red light is absorbed by water, leaving the blues. And that's why blue light is the light that you see when you shine light through water. Okay, well, moving right along, let's take the next listener phone call.
Yeah, hi, my name is John Lucas, calling from WMLI in St. Mary's, Georgia. Recently, NASA ran an experiment with an engine that used no fuel. It was done on the planet at ground level, and it produced positive thrust. Critics have said that they hadn't compensated for the extreme cold of space, and in fact, the heat outside the experiment, or outside of the machine, inside of the closed experiment, was causing the positive thrust. What are your thoughts? Thank you.
Yes, this is causing a certain amount of flutter on the Internet, so let's make this clear. First of all, an electromagnetic engine is basically a chamber that has, let's say, radar or microwaves floating inside. So a primitive version of this would be your microwave oven. Now, the question is, can you use your microwave oven or an electromagnetic drive to drive a spaceship? Well, Newton would say for every action, there's an equal and opposite reaction. Therefore, the two cancel out, unless, of course, you harness it in the form of a rocket. So you have thrust on one side, and you have the propellant on the other side, and you have net thrust. That's the experiment that was done, causing a certain amount of controversy, because physicists would say that you should get zero, or something very close to zero. Now, the authors of this study claim that they get something very small but positive when it should be zero, which means that perhaps Perhaps you can use something like radar or microwaves in order to drive an electromagnetic engine. Well, personally, and this is just my personal bias because I haven't done the experiment, my personal bias is that these people made a mistake, that Newton comes out ahead and the action cancels against the reaction and the thing does not move at all. However, I'm a physicist, and I realize that the ultimate arbitrator is not my feelings, but reality. So the test is going to have to be redone, but among the physicists that I know, uniformly we believe that a mistake has been made. However, who knows? We're always open to new ideas. Physicists are revolutionary conservatives. That is, for the most part, we're very conservative. We don't want to change the laws of Albert Einstein and the quantum theory for nothing. However, once a deviation is found, we accept it immediately once it's verified. So, verification is what's necessary now. As Carl Sagan once said, remarkable claims require remarkable proof. So, getting energy from nothing is, of course, a dream of many a scientist, going all the way back to the perpetual motion machines. But hey, personally, I think a mistake was made, but we have to make sure that the experiment is done once again, and again, and again. Of course, you don't want to build a rocket engine and turn it on and nothing happens, right? You want to make sure it works every single time. Okay, well, let's take the next listener phone call.
My name is Ken, calling from Anchorage, Alaska, radio station 750 KFQD. My question is regarding something I heard about Hitler back in his day trying to control gravity or anti-gravity. I'm not sure. There's something about taking mercury and applying a high amounts of electricity, I think they said. Can you talk about this? Something about the relationship between mercury and very large amounts of electricity in regards to anti-gravity formation. Anyway, I do love the show and wish you were on more. Okay, bye.
Okay, well, you ask an interesting question because during World War II, lots of cockamamie schemes were investigated by not just the Nazis, but also by the United States government because who knows, if just one of these cockamamie schemes worked, it would change the course of World War II. And that's why Adolf Hitler worked on the V-1 rocket. He worked on the V-2 rocket. He worked on the jetpack. The Nazis had an operational jetpack straight out of Buck Rogers. The problem is that it didn't last very long and was rather useless as a military weapon. But Hitler also had the V-1 rocket when in the United States we didn't have any rockets to speak of at all. And also the V-2 rocket, a cruise missile. So, yes, the Nazis were ahead of us, but when it comes to anti-gravity machines, no, I don't think they were able to get that. In the United States, there's talk about the Philadelphia experiment where the United States was experimenting with these things. Again, I think it was a bogus story. So, personally, I don't believe it. However, if somebody could have proof of this, I'll be more than happy to look at it. But at the present time, scientific consensus is, nope, neither the Allies nor the Germans were able to create anything close to an anti-gravity machine. Okay, well, that's it for Science Fantastic. Good day.
This is Science Fantastic.